Alright, welcome back to the SciMax channel. Today I'm going to tell you about a new feature in litdb called deep research. Deep research is a pretty common and new use for large language models, and lots of the apps have it now. For sure, Gemini and ChatGPT both have a deep research button, and it changes the way the response comes to you. So normally with a large language model, if you just give it a prompt, it generates text that is conditioned on that response, and that's that. There's usually no references associated with it because that's just not how it works, and if they are, the references are not always valid. With deep research, what happens is that before it does that, the large language model is used to sometimes refine your prompt, and then there are a sequence of agents that will look up information using web searches or in databases or other means of gathering information, and that information is used as context in the response. And the response is usually from a sequence of steps that includes brainstorming, outlining, summarizing, and then finally generation of the report, and frequently there will be references associated with it from the sources that it used. Now, I've found a package called GPT Researcher that does a lot of that for you, and then I integrated it into litdb so that we can have something that is like deep research, but that leverages your litdb database and OpenAlex for additional context. So today we're going to look at deep research on this question: can I use DFT to simulate radiation damage in alloys? And I'll show you what deep research looks like on the on the sort of client side. Here we have Gemini. There's a button. You click on it to turn on deep research, and you type in your question, and then some magic will start happening. So it's going to show me a plan. Here it is going to search websites for these related questions that sound related. And then it goes through all of these 8 points: analyze, create report, and it sounds okay to me. I don't want to edit that, and so I just click on start research. And then it goes through all of this to show us that these things are happening, and says we can go ahead and leave. So over here it's going through a series of steps for understanding the basics and so forth. So back to while that runs, in litdb we do something similar, and we just have this command: litdb research, can I use DFT to simulate radiation damage in alloys? And I'll go ahead and start that. So here we can just type that command in and hit enter, and this is going to first analyze that query. And here it says that it's kind of too broad and asks for clarification. So you can help focus it by asking or clarifying any of these points on what type of radiation, any particular alloy. If you want a more focused answer, you could ask any of these things, but I'm just going to press enter because I don't want any change. I want to compare what we get. So now it's going to look up some information. So it's going to browse the web and search for questions that are related to this. Here it tells you it's planning the research. It tries to download things. Sometimes that works, sometimes it doesn't. It's pretty verbose what you see here. You can ignore all of these errors for the most part. They are probably more for a developer to ask, how do I get information from this URL? Now it's printing it out. This is just showing you something's happening. Eventually it's going to render that as Markdown with references, and it's going to turn into something that's black. So this is the rendered Markdown from that. So it gives us a little title. You can read through this and see what is radiation damage, what is DFT, how DFT is used to calculate some things, advantages, limitations, addressing limitations. So this is a much richer response than you would get just by putting this into ChatGPT or Gemini. You see it has references. We'll look at those at the end. Alternatives, including cluster expansions, some specific systems, role of machine learning. I didn't even ask about machine learning, but that's what came up. And then we have all the references down here. We can click on one of these and see where it goes. See, here it thinks I'm not a human. Click the images of the animal this body part belongs to. Wait. And then we get to enabling strain hardening. And that is what I clicked on. So these should be all real references that came from the research that it did. And there's lots of them, so you can follow up and read as many of them as you want. And then there's a big line, and it has a cost here. So it looks like it cost about 12 cents to do this. The 12 cents came from all the tokens that were sent to a large language model. In this case, it was Gemini. And maybe there could have been some search charges associated with using Tavily if that happened. Anyway, it's pretty cheap at 12 cents compared to what it costs to use deep research in ChatGPT, for example. It's more expensive than the free Gemini use that I have, but I have a lot more flexibility in what happens here. Okay, so there are some things that you can look at. Let's look at the help real quick. litdb research-help. There are a couple of options. We can specify a report type. There's a default that's specified. You can give it a path to local documents if you want to use those in research. And you can specify the output file path name with -o if you wanted to save that so you could look at it again. Okay, so that's sort of that. Let me just show you briefly how I have it set up. Like I said, there is a package, GPT Researcher, that does a lot of this for you, and all that's happening in litdb is that's wrapped, and we use, I added this initial query refining step, so it's more like what I am accustomed to with ChatGPT. We use a vector search to find related content in your litdb, and a full text search for related content from litdb. And finally, we add OpenAlex queries that give you at least title and abstracts for adding additional content. So roughly the way this works, we have this config that is your litdb.toml. We get our database. We set up an environment variables. That's how GPT Researcher works. So it looks for environment variables for PubMed, Google, Tavily, and you have to have your cloud LLM APIs for Gemini, Claude, or Anthropic, or ChatGPT set up as well. There are some other retrievers available, but I haven't used them, so I don't fully support everything in GPT Researcher here. You can use Ollama as your LLM, so that's the default if you don't set up anything. And of course, you have to have it running and installed to work with Llama 3.3. That's a big model, so you need decent hardware for it, at least 50 to 60 gigabytes of RAM probably. I run it on a 64 gigabyte Mac Mini, and it works pretty well. In terms of retrievers, we start out with Archive, and then if you have your PubMed key set up, you can get PubMed. If you set up a Google CX key, you can use Google. And then if you have an API key for Tavily, you can add that. And those are just different sources that GPT Researcher can use. I have a documents function here. So this is to add documents to the researcher from your litdb. And we use a vector search here with the query. I hard code 5 here. Maybe I should make this configurable one day. But this will find the 5 nearest vectors in your database and then use those documents here as lang chain documents. Then I do a full text search, so I use a large language model to generate large full text queries from your query, so it picks out good keywords and combinations of them, and then for each one of those I get a full text query down here and add that as a document, and then finally I run a OpenAlex query for each one of those keyword queries and add those as documents. So in theory, there could be a handful of extra documents from OpenAlex. The query does get refined, so here I use a large language model to take your query and analyze it to see if there are things that could make it more specific and focused, and then I give you an opportunity to revise it down here, and if you press enter, it just replies with make no changes, generates a new query, and that's what goes in to the report. So the logic for getting a report is to take your query, refine it, generate a researcher with those documents, and I should probably delete this for now because that used to be in there, but it's just a comment. And then we conduct our research, we write our report, and then we get some additional information that just gets returned. This is an async function, and so we have a second function over here that we use async.io.run, which just gets that report and returns the results. And this is wrapped in the CLI.py. So the research command is defined here. We give it a query. Usually I quote it, but you don't have to as long as you don't do anything that's illegal in shell syntax. And then we can specify the path to a folder of local documents, and those will get indexed. And you can change the report type if you want. And then otherwise it just runs the deep research function. And then here's the report that it gets generated. And if you specify to save it, it will save it out to a file. I can't decide if that should be a default. It would overwrite previous ones, which might not be desirable. On the other hand, it's annoying to remember to put it in every time. Okay, so let's go back here. This is finally what was in Gemini. So Gemini has it over here. It has a similar kind of rendered format. It's probably longer, but it shows similar principles of density functional theory. It's quite long there. Radiation damage mechanism. That's like that. If you click on these, it has references that are in each one that you can look at. Here's a DFT. So this is maybe longer than what I got. I don't know if that makes it better. Some case studies similar to what we saw. Similar limitations. Combining DFT with other things like MD. Recent advances. Conclusion. And then these are, all of the sources. Maybe there's more sources. Again, I don't know if it's better or worse. This one is free for me to use because of the agreement we have through the university I work at. But I believe they made deep research free for all people using Gemini. There's nothing wrong with using Gemini as it is, but this one definitely doesn't have the integration with litdb and the other and the flexibility to add different retrievers and do things kind of your way. So that brings me, to the end. And just as a example of deep research and litdb, you can check out the GPT Researcher if you don't want to use litdb. It's got a lot of really interesting things in it, including its own command line tool and other ways of installing it in npm in Python. There's Docker images for it, etc. But I wanted something that was tied in with litdb because I use it for so many other things that it seemed like a good idea. So this is almost certainly still kind of alpha stage. I'm still learning a lot about GPT Researcher and various ways to integrate what they have into a package. I sort of made up this idea of including the OpenAlex features as additional documents instead of as an additional retriever. There may be other ways to integrate it and other ideas that come down the road, but I think it's likely to work more or less like I showed it here. litdb, space research, you give it a query, and the rest is really how you configure it and control it and use it past that. So thanks for listening, and stay tuned for the next features that will be talked about in litdb. Thanks.